Hello everyone. So today we will be discussing design of beams. Now, what is a beam? It is an important element of a structure and is normally horizontal. Okay, and it has resistance to bending and shear. Okay, it is horizontal. It has resistance to bending and shear, and any structural member could be considered as a beam if the loads cause bending of the member. Okay, and beams are mostly used to support floors. So now if we go into the different classifications for beams, there are four classifications: class 1, class 2, class 3 and class 4. You can write it down. So class 1 is called as plastic, class 2 is called as compact, class 3 is called as semi compact, and class 4 is called as slender. Okay, now the quality decreases from class 1 to class 4. Class 4 are having the lowest quality and class 1 is having the highest quality. Okay, now let us go into the characteristics of these four classes. Now see here, let us go from the bottom, class 4. So it is said as a slender section. Class 4 is a slender section. What does it mean? You see here, there are some curves that I have drawn. So using these curves, I will be trying to explain it to you. Okay. I hope you have till now remembered the concept of My and MP. My is the yield moment and MP is the plastic moment. So what what is the main meaning of yield moment and plastic moment? You see here, suppose I am taking cross sections. Okay, same cross section for both conditions. Now if the moment reaches yield moment, it means that the extreme fibers, that means this one and this one, will reach the yield stress Fy. Remaining fibers here and here, they will not reach Fy because they are less. Okay, only the Fy value is reached by the extreme fibers. So at that point, the moment will be called as the yield moment. Now, what will happen in the plastic moment? Each fiber will reach the yield stress. So the diagram will be so. This we have already discussed. Okay, in the plastic stage, what happens? So each of the fiber, this fiber is also having yield stress Fy. This fiber will also have yield stress Fy. This fiber also, this fiber also, this fiber, everywhere it is Fy. So we can judge from here that MP is obviously greater than My, and when the load is MP, when the moment is MP, plastic hinge is formed. Okay, so that is the concept of My and MP. So My is reached earlier than MP. Okay, at My, the extreme fibers reach the yield stress, and as we keep on increasing the load, the all the fibers reach their yield stress Fy. So what happens to the slender section? In the slender section, the curve is this one. So here what happens is that even before the extreme fibers reaching Fy, it buckles. Okay, it bends. And as you can see here, for slender sections, the situation will be such that these extreme fibers will not even reach Fy, but still it will buckle. Okay, so this is the behavior. Okay, the elements buckle even before reaching the yield stress. Now, what will happen to the semi-compact section? The semi-compact section curve is this one. So for semi-compact section, the fibers, extreme fibers will reach yield stress. Okay, the extreme fibers will reach yield stress, and then there will be some buckling. Okay, but it cannot reach MP. I repeat, semi-compact sections are those sections in which they will reach yield stress, okay, and they will have some buckling, but they will not reach MP. Plastic movement they will not reach. Okay, so for them, if we draw the diagram, it will look like this. So these extreme fibers Fy. So the situation will be like that. Next we go to the compact section. What will happen is that in compact section, they will develop the plastic moment of resistance. Okay, so all the fibers will reach yield stress. Okay, and they will have there will be buckling. Okay, there will be buckling in the compact sections, and finally for the plastic sections, they will reach the plastic moment, and they will form plastic hinge, and they will rotate because of the plastic hinge. Okay, once again I am repeating, the curve for the plastic sections will be like this. It will reach the plastic hinge, plastic moment, and then from the plastic moment, since it has developed the plastic moment and the plastic hinge, it will have rotation capacity. It will rotate like this. Okay, and ultimately the difference you need to know among all the four, the compact section will reach the plastic moment, but it cannot develop the plastic hinge. Okay, but the plastic section will reach plastic moment and will develop plastic hinge and will rotate. Okay, then the semi-compact section will reach yield moment. Okay, and the slender section will not even reach yield moment. Okay, so these are the four differences that you need to know. Okay.